keep our Oxy-Fuel torches. So I'm gonna take it, I'm gonna wheel it on over here, where I'm gonna show you how we cut. Everybody gather around, everybody gather around. You'll have plenty of time to do your other stuff.
Oh.
You see it? Oxy-Fuel torch. Face this way so you can see the pressures, all right? So, your oxygen tank is this big green one that says oxygen, okay? This red tank is your fuel. In our case, we use what's called acetylene. You can use different types of fuel sources, but we use acetylene because it's the best for welding when you do Oxy-Fuel welding, okay? So to get set up, we have our torch right here. Our torch is currently set up for cutting because we are doing an Oxy-Fuel cutting assignment, all right? So we have quick connect torches. This is a torch body. Does that make, or a cutting head for the torch body. Does that make sense? You see that? This is for cutting. We have other attachments for different purposes. This is for heating up parts. So if anybody ever works on old rusty pickup trucks, this is what you use, okay? If anybody has ever done Oxy-Fuel welding, you use one of these. They're very interchangeable to change, but we are doing Oxy-Fuel cutting. So here's your torch body, cutting head goes in, we tighten it up. Does that make sense? So now we have that set up, ready to go. Now we need to set the pressure on our tanks. Now they should always be at 0, 0 when you start, because when you get done, you should bleed the lines, and these should be threaded all the way out. That way there's no line pressure on this in case something accidentally sparks and this goes boom, okay? If there's no line pressure, we should be okay, right? So we always start A before O, A before O. Why? What comes first in the alphabet?
A.
Yeah, there you go. So remember that. Think the alphabet, A comes before O. Okay, so we'll start with the acetylene. We're going to start by setting the pressures on the tank, then we'll move to the torch. That sound good to everybody? So, firstly with our acetylene, we quarter turn and crack the bottle open. That's it, just a quarter turn. In case of a fire or anything like that, that way we can quickly kill the fuel source. Does anybody know the fire tetrahedron? 3 things you need for a fire. Oxygen, fuel, heat, and or ignition. Okay, so if you kill the fuel, then there's no fire. Okay, so quarter turn. Then you take the regulator. Okay, this is the regulator. And you're gonna thread it into 6 PSI. 6 PSI. What PSI? 6. Okay, now you're good with that. Now oxygen, okay? Oxygen, we're gonna move on to that. Oxygen's good, that's what we breathe in. In theory, you could take this regulator off, go crack it open, get a lot of oxygen. I wouldn't, but you could. All right, so this one we can open up all the way. All the way. All right, and now we're gonna set this one, okay, to 9 PSI. 6 PSI, 9 PSI. 6 PSI, 9 PSI. Do you think we can remember 6 and 9? Okay, I figured. That's why we do it that way, so you remember. Okay? Now again, depending on the applications, your pressures could be different, but this is could be different. This is just a pretty good rule of thumb. 6 and 9. Does that make sense? All right? So now I'm going to thread in this regulator to 9 PSI. So if you look at this gauge, PSI is on the inside of the gauge. So that needle barely moves, okay? Because our first marker here is 50 PSI. So 9 PSI is way down here. That gauge barely moves. Again, if you use thicker steel, stuff like that, you might have to turn up these pressures. There are charts and stuff like that online for you to know. So that's a good rule of thumb. All right, now we get to the torch. All right, so I'm gonna get some metal set up. Here, grab me one of these. So like this. This is a perfect thing you could cut 4 or 5 4-inch cuts in. Does that make sense? An old dirty piece of metal. So I'm gonna set this up just like this. That's how I'm gonna cut. Try not to cut onto this table, otherwise it gouges and wrecks the table. That's why we're gonna build some Oxy-Fuel cutting stations here in a sec after we're done with this project. So now you go to the torch. You wanna make sure everything is closed to start. Remember, righty-tighty. So if you spin it to the right, which is also clockwise, it should be shut. If you spin it to the left, lefty-loosey, that's all the way open. If you don't know either of those, that's a problem. But we can help working on our rights and lefts, okay? So, what you're gonna do, again, A before O. Quarter turn your acetylene. Quarter turn your acetylene, open up your oxygen all the way. This is just for cutting. For heating and for welding, it's a little different setup, okay? So oxygen all the way, acetylene quarter turn. Our mixing valve, this is our mixing valve. This stays shut. Then I grab a flint strike in here, all right? Everybody always tries to go like this, and a lot of times it won't light. I always try to have an up-hand grip, using my pointer finger. That allows me to push down and add pressure. So even when the flint is wearing down, this still allows me to add pressure to that strike pad. Does that make sense? So now I'm gonna light it. It will be bright when you light it. This isn't as bright as welding, but you still need to have some protection. So whether you wear a welding helmet or one of our green tinted face shields, okay, you still need to have some eye protection, otherwise you will hurt your eyes. A lot of times if you look, they have what's called Oxy-Fuel goggles. They're like a shade 4. You wear those, you don't have any. Okay, so I'm gonna light it. Cool. So if it's hissing like it was, that means there's a little bit too much acetylene. Does that make sense?
Yes.
So I want it to look like a campfire where I'm rolling coal like those diesels in the parking lot. You see that?
Oh, yeah.
Cool. I take my mixing valve, I'll mix it in. Nice and slow. And you see my little white wings here? I want those to be even, the same length right there, like an 1/8 or a 1/4 inch long. You guys see that? Okay, should look like a gas stove. This is really, really hot, all right? And then this handle, this pushes the heat through. So sends oxygen through, that's what cuts through our metal. So what happens is I'm gonna start this on the edge of my metal. Once it gets cherry hot, I'm talking red, red, red hot, I'm gonna press this. You're gonna start seeing sparks coming through, you're piercing through the metal, then you move at a nice consistent speed through the metal and it will cut. Sometimes you go too slow and it ends up filling itself back in. Sometimes you go too fast and now it's not cutting anymore. You gotta restart. Does that make sense? So let's take a look. So I'm gonna start here. This will cut as straight as you hold it. So I'm gonna cut here, I'm gonna get that cherry, cherry, cherry red.
6, 7, 6, 6.
Right there. And now I should be good to
6, 7. Like 6, 6.
Ew. And there is a cut. Now if you do it really good, it just falls right off. Okay, but there's just a little bit left so I can wiggle that free. Right? Now to turn it off, what I do? Again, A before O. Kill the fuel, close the mixing valve, turn off the oxygen. Does that make sense? And that's how you cut it down. So once that's all off, and you got all your cuts done, you have to bleed the lines on these. So how that starts is you close the bottle again, A before O. Close it, 1/4 turn back. Open the mixing valve a little bit, open the acetylene, those gauges go to 0. And you close it back up so it's ready to go for the next one. Then we go to oxygen. We spin this shut. Open up the oxygen valve, open up the mixing valve, those gauges go to 0, lines are bled, and we are good. Does this make sense to everybody? Okay, so how many cuts do we need?
5.
Yes, how long?
4 inches.
4 inches. So it's gonna happen. Landon's gonna grab a piece of metal, he goes, I'm gonna cut here, 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 and here. And now I'm gonna be like, yep, and then you're gonna bring me piece 1, 2, 3, 4, and 5. That makes sense? Yep. All right, let's get to work. Ready, break!